This one, notice we have x's in the base and the power. So when you have, right over here, whenever you have x's base and power, hope you're used to it by now. We're going to L in both sides, right? That's what gets powers to come down. So that's our first step. Let's just go y equals, and I'll just do the function. I'll come back to the limit in a minute. Let me just deal with this function first off. Over x. So then I'm going to L in this side and L in that side. So we always do. That's what brings powers down, is the L in. And then that power drops down. That's not one of the, it's the greatest quality of the log. It brings that power down. So then we have ln y is 10 over x ln 1 plus 12x. Okay. Now remember, don't forget, we're doing the limit, right? Limit as x goes to 0 on the right. So if I squeeze in that limit now, I'm going to take the limit. X goes to 0 from the right. If I put in a 0 there and a 0 there, what am I going to get? I'm going to get 14 over 0 from the right times ln of 1 plus 12 times 0. That's just 1 plus 0. So then now that's positive infinity. Why? Because anything over 0, remember the denominator, the bottom goes to the top, 0 goes to 14, infinite times. It's positive over positive, it's positive infinity. ln of 1, and what's ln of 1? Well, it's 0. You can show you in Desmos here. Um, here, ln. Well, you can see it up there. See how ln 1 is 0? It's part of another problem, but there it is. So ln 1 is 0. So this is infinity times 0. Now what's that? It's infinity times 0. It's indeterminate. It's unclear. We just don't know. We can't determine it. Why? You might think, yeah, anything times 0 is 0. Well, this isn't a real 0. It's just close to 0, remember? Because x is just getting really close to 0. So that therefore this is close to 1 and this is close. It's just a close to 0. It's just a tiny number, like 1 millionth or something. And this is a really big number. So what do? We don't know. The bigger one's bigger, they might go somewhere. The smaller one's smaller, they might be 0. Who knows? It's indeterminate. We cannot determine it. So that's what we remember. Oh yeah, that's right. They wanted us to use L'Hopital's rule. How's that work? So that is, remember how that works. Whenever you have 0 over 0 or infinity over infinity, then you're allowed to take the derivative of the top and the bottom separately. Separately being the key word, not quotient rule, separate top and bottom. Whenever you have 0 over 0 or infinity over infinity. Well, so therefore I think, oh, so we don't want this infinity times 0. That's just unclear and indeterminate. We don't know. Let's make this a fraction. You know how we do it, right? We've done it a few times now, right? We're just going to go, okay. So it's going to just leave the L in on the top. 1 plus 12. And then grab that other guy and flip it upside down to the bottom, right? Remember how that, remember multiplying is the same as, is upside down dividing, right? You can divide by the same thing upside down, it's the same result. Think about it. You just think about numbers. If I go 10 divided by 2, that's 5. If I go 10 times a half, half of 10 is also 5. So dividing by a number, same as multiplying by the upside down or vice versa. So multiplying by 14 over x, the same as dividing by x over 14. So that's what we do now. Now, why would we do that? Because now if you plug in the 0, x going to 0, put a 0 there and a 0 there, see what we're going to get? We're going to get, this will equal ln of 1 plus 0 over 0 over 14 now, which is ln 1 over 0, 0 over 14 is 0. ln 1, 0, 0 over 0. So that means Lopi. Now we can use L'Hopital's rule. Why? Because we got 0 over 0, right? When I plug in x is 0, there and there, it comes out 0 over 0. And that's the requirement. When you get 0 over 0 or infinity over infinity, you're allowed to you do Lopi. And what do you do when you do Lopi? You do the derivative of the top and bottom separately. So I'm going to go, all right, Lopi to the rescue. Put an H over my cosine. Everybody know I'm doing Lope. So then, okay, so it's limit. X goes to 0 from the right. And now let's do Lope. So what does that mean? Derivative of the top all by itself. This is not quotient rule. I'm not doing taking turns and divide by the denominator squared. No, I hate the quotient rule. This is not the quotient rule. This is L'Hopital. And so that means separate top, separate bottom. How do you do the derivative of natural log of anything? 1 over the argument times, because the inside's not a simple x right in here, derivative of the argument should be just 12, because the 1 doesn't do anything. 12x is 12. Okay, now the bottom, I'm going to write this 114. I'm going to scribble it up. I'm going to say this is 1/14 x, right? That's what that is. So the derivative is just 1/14. Okay, the 1 power comes down, subtract 1, the x is gone. So I do the derivative of the top and the bottom separately. That's what L'Hopital said I could do. Derivative of the top separately, bottom separately, not quotient rule, top and bottom separately. All right, now what? Well, now let this guy flip back up. Now he's done his derivative. Now flip him back up, and he's what? He's 14 over 1. I scribbled that. Just such a mess here, huh? 14 over 1, right? Because dividing is upside down multiply. So then we go, oh, okay, limit x goes to 0 from the right. Close now. We don't have anything at the bottom here. Don't even need that bottom here. This is gone. He flipped up to the top. So I've got 14 over 1 times 1 over 1 plus 12x times 12. This is really over 1. So this guy's going to the top. This guy's going to the top. And we are almost done with this thing. Limit x goes to 0 from the right. So that'll be 14 times 12 on the top over 1 plus 12x. Now, let x go to 0. Boom, x goes to 0. So then this is just 14 times 12 over 1. 1 plus 0, which is 1. This is just 14 times 12. Now, careful, we're not done. Remember what that left side was? I kind of lost left side. Should have been bringing it along all the time. It's ln y. It's not y. It's ln y, ln y. So careful, whenever you ln both sides, you got to remember to finish her off. So we have ln y is 14 times, right? ln y is 14 times 12. How do you get rid of that at the end? You e both sides, right? Boom. Y is e to the 14 times. You can multiply that or just type in 14 times 12. There it is. It's e. We're always going to finish off whenever we have, there's the right answer. Whenever we have x's in the base and the power in the beginning, we know we're going to ln both sides. And that means we're going to have an ln y on the left. And the very last step to get rid of that is we're going to e power both sides, or take e to both sides. And there's our answer. E to the 14 times 12.